Hello everyone, let us continue the solid state. As we were discussing about crystal lattice and unit cell, let us recall this. Consider a crystal. We know that the main characteristic of crystalline solids is its regular and repeating pattern of constituent particles. Now, when we replace these particles with representative points, a crystal lattice is obtained. Crystal lattice is defined as the three-dimensional arrangement of constituent particles represented diagrammatically such that each particle is depicted as a point. Such an arrangement is known as crystalline lattice. There are 14 possible three-dimensional lattices known to us. These lattices are named after the French mathematician who first discovered it. Thus, they are known as Bravais lattices. Now we know what is crystalline lattice or crystal lattices. Let us study some of its characteristics. Each point in a crystal lattice is called lattice points or lattice site. Each point in a crystal lattice represents one constituent particle, which may be an atom, ion or molecule. Now, if we observe this crystal lattice, we can notice that there is a small group of lattice points that repeats itself again and again to form an entire crystal lattice. This small group of lattice points is known as unit cell. Therefore, unit cell is the smallest portion of a crystal lattice. When repeated in different direction, generate entire lattice. A unit cell represented by three edges A, B and C represented along X, Y and Z axis. Please note that these may or may not be mutually perpendicular to each other. In some cases, they are perpendicular to each other and in some, they are inclined to one another. In this unit cell, angle between edges B and C is alpha and angle between edges A and C is beta and angle between edges A and B is gamma. Overall, the unit cell is characterized by 6 parameters, that is A, B, C, which are its length, alpha, beta, gamma, which are its phase angles. There are 7 possible combinations of A, B, C and alpha, beta, gamma, forming 7 types of unit cells. These are also called crystal system. The 7 possible combination of A, B, C and alpha, beta, gamma are as follows. The cubic unit cell. In cubic unit cell, you can see A is equal to B, which is equal to C. So all sides are equal. All edges are equal and angles alpha, beta, gamma are equal to 90 degrees. They are mutually perpendicular to each other. Second one, tetragonal unit cell. Here only 2 sides or 2 corners are equal. Either it may be A and B. Here A is equal to B, but it is A or B is not equal to C. C will have different value. You can notice this in this diagram. Here these 2 lengths are equal to A, which means A is equal to B, but C is different. Here angles alpha is equal to beta is equal to 90 degrees. Alpha, beta, gamma is equal to 90 degrees. So all the angles are mutually perpendicular to each other. Coming to the third type of crystal system, it is orthorhombic unit cell, where A is not equal to B and B is not equal to C. So all the sides are different values, different unit. A is not equal to B and B is not equal to C. So all the three lengths will be different, but they are all perpendicular to each other. So alpha is perpendicular angle alpha is 90 degrees, beta is 90 degrees, and gamma is also 90 degrees. Coming to the fourth type of crystal system, which is hexagonal unit cell. Here you can notice in this, alpha A is equal to B. We can see A is equal to B, but it is not equal to C. A is equal to B, but it is not equal to C. And one more thing you can notice here, alpha is equal to beta is equal to 90 degrees. Alpha and beta is 90 degrees, whereas gamma is 120 degrees. Gamma is 120 degrees. Coming to the fifth type of crystal system, which is rhombohedral unit cell, which is also called as trigonal unit cell. Here all A, B and C are equal. Even alpha, beta, gamma is also equal. It is very much similar to cubic unit cell, but here angle is not equal to 90 degrees. Alpha is equal to beta, beta is equal to gamma, but it is slightly tilted. Okay, so here A, B, C, its lengths are equal. Alpha, beta, gamma angles are also equal, but only difference is it is not equal to 90 degrees. Coming to the sixth type of crystal system, which is monoclinic unit cells. Here all the three sides are not equal. A is not equal to B and B is not equal to C. Here alpha and beta, alpha and gamma are 90 degrees. Gamma is 90 degrees, alpha is 90 degrees, whereas beta is not equal to 90 degrees. So in monoclinic unit cell, all the three sides are different. All the three sides are different dimensions. Alpha and gamma are equal to 90 degrees, whereas beta is not equal to 90 degrees. Coming to the last type of unit cell or crystal system, which is triclinic unit cell. Here no parameters are equal to each other, either length or angle. Here A is not equal to B and B is not equal to C. Alpha is not equal to beta and beta is not equal to gamma. So all the three lengths are different. All the three angles are also different. So this kind of crystal system is called as triclinic crystal system. Let us tabulate all these characteristics in the form of table. Dear students, please memorize these characteristic properties as they appear in competitive examinations. See, I have tabulated this all 7 primitive unit cells and their possible variations as centered. Crystal system, cubic, you can see there are all the parameters are equal. A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degrees. For example, sodium chloride and zinc sulfide. The possible variations, it is primitive, body center and face center, which you are going to learn the next slide. Okay, next tetragonal, where A is equal to B but it is not equal to C. Alpha is equal to beta is equal to gamma is equal to 90 degree. The example is white tin and tin dioxide. Orthorhombic, Here A, B, C are not equal to each other. Alpha, beta and gamma are equal to 90 degrees. Example, rhombic sulfur or potassium nitrate. Rhombohedral or trigonal crystal system. Here A is equal to B is equal to C and alpha is equal to beta is equal to gamma, but it is not equal to 90 degrees. Example, calcium carbonate and silver sulfide. In case of hexagonal crystal system, A and B are equal, but it is not equal to C. Here alpha and beta are equal to 90 degrees and gamma is equal to 120 degrees. For example, graphite and cadmium sulfide. Monoclinic crystal system, alpha beta is equal to 90 degrees. Alpha and gamma is equal to 90 degrees and beta is not equal to 90 degrees. All the three sides are not equal to each other. Where A is not equal to B and B is not equal to C. In case of triclinic, all the 6 parameters are different to each other. All the parameters are different. A is not equal to B and which is not equal to C. Alpha is not equal to beta and beta is not equal to gamma, which is not equal to 90 degree, which is not perpendicular also. So example, potassium dichromate, calcium sulfate. Now let us see the types of unit cells. Based on the position of constituent particles in a unit cells are broadly classified into primitive unit cell and centered unit cell. Primitive unit cells, when constituent particles are present only on the corner positions of a unit cell, it is called as primitive unit cell. It is denoted by the letter P. You can note here the constituent particles are present only on the corners of a lattice point. Second one is centered unit cell. When constituent particles are present not only at the corner position but also at some other positions within the crystal, then that cell is known as centered unit cell. Apart from the positions in primitive unit cell, if you find any other constituent particles inside a unit cell, then this kind of unit cells are called as centered unit cell. Centered unit cells are further classified into body-centered unit cell, face-centered unit cell and end-centered unit cell. In body-centered unit cell, one constituent particle such as atoms, molecules or ion is present at the center of the unit cell, in addition to the particles present at the corner positions. Body-centered unit cell is denoted by the letter I. You can notice apart from primitive unit cell, there is one more constituent particles present in the center. So this kind of unit cell is called as body-centered unit cell, where the constituent particle is present in the center of the unit cell. In case of face-centered unit cell, the constituent particles are present not only at the corners, similar to primitive, not only at the corners, but also at the center of each face of the unit cell. You can see in each face, center of each face, there are one particles, constituent particles. So face-centered unit cells or in this type, constituent particles are present not only at the corners but also at the center of each face of the unit cell, and it is denoted by the letter F. in case of end-centered unit cell, the atoms are present on the corners and on the centers of any two opposite faces. Not in all the face, but only on the opposite face, centers of the opposite face, any two opposite face. If you find a extra atom or ions or molecule on center of any two opposite faces in a primitive unit cell, then this kind of unit cells are called as end-centered unit cell. Let us continue how to calculate a number of particles in a unit cell in the next video. Thank you for watching this, and if you have any doubts, please feel free to ask me. Thank you.